Okay, so here's a video example for number 3. A 12-meter boom AB of a crane lifting a 300-kilogram load is shown below. The center of mass of the boom is at its geometric center, and the mass of the boom is 1,000 kilograms. For the position shown, calculate tension in the cable and the force at axle A. Okay? All right, so this is pretty common. This is pretty much how all these problems look. Okay? All right, so you're going to have FG of the... that's not the boom. The load? I guess we'll call it FG of the load. Okay, FG of the boom, right? Which means the boom is the, thing that sticks out. And at this pivot point here, you're going to have, we'll just call it FX and FY. And then you have this tension force here at this really small angle, FT. Okay? All right, so now you have to see if you're going to be able to keep this in equilibrium. You have to sum the forces and sum the tensions. Sum the torques, all right? So the first thing we want to do is probably split things into its components, because remember, the force has to be perpendicular to that distance from the pivot point, okay? You can also do it by making the distance perpendicular, so I'll show that after, right? In this case, that might make more sense. Well, I don't know. So you can decide. All right. But I'll show you that in a minute. All right. Okay. So, let's go ahead and look at the boom again. Right. So I'm going to have, this is my angle 30. Okay. And then this is my 2 FGs, right? So we really only care about, let me draw this differently. We really only care about the perpendicular components, right? So we're going to have this FGL, I don't know, Y, perpendicular, whatever. Okay, FG boom Y. All right, and then if we think about that angle there, right, that was the original one. Okay, so if that's 30, and I'm kind of thinking of this like a triangle, right, that would be 60, so that is going to be 30, I think, right? That should be the same angle. Okay, and then this tension here is at this 10-degree angle. All right, so this FTY, all right, is going to be the sine component, right? Because it's going to be the opposite component, 10, okay? All right, so I'm going to probably just do FTY. I'm going to do FT sine 10, FG load Y. I'm going to do FG load, let's see, what the heck is that going to be? That's the angle, so it's going to be cosine 30, and then FG boom Y, FG boom sine, cos 30, okay? All right, and so to make these a little bit easier, right, this one we can't really change, but I'm just going to go ahead and get a number for FG load cosine 30, right, because we know those masses, okay? So just to kind of make it easier down the road, so I don't have to write all those components because it's just I don't have enough space on here. Okay, so let's see, the load is 3,000 kilograms, so times 10, and then times cosine. Oh, I should have done cosine of 30 first. I need a real calculator. Oops. Okay. All right, clear. 30 cosine, okay, times 3,000 times 10. I hope I'm doing this right. 25,980. I'm just going to round it, okay, to keep it simple. Could be 981, but come on, that looks like a lot of sig figs. Okay, and then cosine of 30 times the boom itself is 1,000 kilograms times 10. So that's going to be 8660 newtons. Okay, that'll just make it a little easier later. Okay, all right. Okay, so once you have all of that, all right, then you're going to have... let's do the torques first, right? Because then we don't have to worry about this X and Y. Okay, so the sum of the torques is 0. Let's say this way is positive. Okay, so my FGLY, okay, times the length of the boom, okay, plus FGBY times half the length of the boom, right? Because that's halfway up. Okay, equals, the only thing trying to hold it the other way is that tension. So that's FT sine 10, right? Times the length of the boom. All right. So if you notice, see the length cancels out. That happens a lot. This one, they happen to give it to you, but I know in one of the web assigns, they don't give it, right? So you probably want to just try to, you know, think about that. Okay, so wait, that's pulling positive, positive, negative. Okay, so I'm just going to cancel out all these L's. So my FGLY was 25,980 plus 8660 over 2, right, is going to be my FT sine 10. Okay, and so then this divided by 2 plus 25,980. Okay, so 3310 equals FT sine 10. Okay, so divided by sine 10 is 174. Sorry, 549. I'm just going to say 550, right? Let's just round it a little bit. 550 newtons. Okay? All right. Let me drink something because I'm choking. And I don't want to start over. Okay. All right, so there goes the tension. Oh my God, I don't know how to pause this. I'm really sorry. But seriously, like, I'm choking on something. Okay. And I do not want to do this whole thing again. All right, here we go. Okay, so now we know the tension in the wire. Now we're going to sum the forces in the X and the forces in the Y. Okay, so here, remember, I had this Fy and this Fx. Okay, so now I don't care any about the components. Okay, I only care about the tension component. Did I do that right? 10. This is so hard to see it. Oh, yeah. Oh, now when I sum it, that's going to be a hassle. Oh, brother. Yeah, I guess that's fine. Okay. I'm going to have to think about that. All right, so in the X direction, right, we're going to have f of X is going to be ftx, okay, because that's the only thing we have. And then the Y, we're going to have Fy is going to equal Fg load plus Fg boom. Okay, and the tension is pulling, I guess, also sort of down, right? So then plus Fty, okay? And I'm not sure that's going to be the same. You're going to have to give me a minute to think. Okay? All right, so my Ftx, let's look at that one because that one's, for some reason, making me feel confused on a Friday. Okay, so if that goes like that way, right, now we want to have an X direction and a Y direction, okay? So then, how are we going to do that? Oh, I hate this problem. Let's think. Geometry-wise. Okay, so if that's 10, then that's 10 also? No, because that's not a right angle. Where is the 10 going to be? Oh my God, I'm going to start this whole problem over. So that's 10. How come I can't see this? Maybe you see it. If you do, then just go on. Why can't I see this? What is happening here? Where's the 10 at? Okay, let's try this again. See, even I'm confused. Maybe if I change colors. Okay, so here, okay, is the FT, right? And I need, before I had this component, right, which was the perpendicular, which was fine because that was definitely sine 10. Okay, so that was fine. Okay, so if I have this, but now I want to have a downward component and a sideward component. Okay, so that whole thing is 10. Oh, I probably have to go off of the 30. No, because that's, oh, that's tricky, right? Is this 30? So that whole thing is 30, right? So that's 20 and that's 70. Does that make sense? Because that whole thing, right? Because if you're looking at it here like this, that's 30, so that's 30. But then you have this little tension at this whacked angle in here. Oh, man. Okay, you know what? I'm going to hope that that's 20. I'm going to hope that that's 20, and then we're going to go from there. Yeah, I think it is, right? Because that angle is both 30. Ugh, what a mess. I hope this is right. This was one on WebAssign. Aren't you glad I didn't give it? Okay, so I think this will be 20, right? So then it's going to be cosine 20 is going to be the X, Ft cosine 20. Okay, and then whatever, and this is going to be Ft sine 20. All right? So let's see. So sine, yeah, because that's going to be small. Okay, I think that's right. Let's go with it. Wow, what a mess. Okay, and then my FG load was 25,980, and this was 8660. Okay, all right, now I just got to solve it because I know the FT. I hope that's right. If it's not right, then someone's probably going to tell me. So if you think it's wrong, could you tell me? Because my brain's tired. It's Friday. Okay, so now let's just get the answers. But wow, that's a really tricky one. I didn't really mean for it to be that tricky. You're not really going to have to do that on the AP test. I don't think that's a little beyond. But college, yes. Okay, 163,976. Okay, and then this one is going to be FT was 174,550. Sine 20. Oh, Lord. 4550. Okay, so that's 25,498. Okay, plus 25,980 plus 8660. Okay, so that's 60,138. Boy, very exciting. Okay, now you're just going to put it back together. Okay, so if my x is 163,976, and this is 60,138, then you're just going to use Pythagorean theorem. Right, so 163,976 squared plus 60,138 squared equals, f squared. God, I wish I didn't give Carl my other calculator this morning for the PSAT because this is a real hassle on here. Okay, plus 60. This numbers might be wrong, y'all, because this is really hard to do on the iPhone. Oh my God. Square root. Yeah, maybe. 174,656 newtons. Okay, that's the force on the boom. Okay. Ooh, ugly. All right, but you get the basic idea. It's probably not going to be this complicated. This one's a little bit nasty just because that angle is really stupid. But I think that's right. But if anyone has a differing opinion on what this angle is and you'd like to explain it to me, then just shoot me an email. Okay? Thank you.